guys might even wondering how to get a kind of unique shot, a drone shot that can pass through a small gap in a safely manner. Today, it can be achievable using this kind of drone, and this drone is called a Cinewook. I'm Nizar Harith and today I'm going to teach you on how to build this drone. Alright, before we start building the drone or a Cinewook, which I prefer call it, I will show you each part of the component that are crucial in building the drone. Just to let you know that all the components that will be shown in this build are the basic parts those are needed for a drone to fly functionally well. Other auxiliary components such as GPS and magnetometer will increase functionality of your drone, but for the sake of simplicity, I will not show it here. And you can buy all of these components from online stores such as Shopee, Lazada, or Vanguard. I will also recommend which brand and type of the component that I'm currently using in my build. The first part is the frame. The frame is basically a lightweight and robust carbon fiber plate that has been modified to hold all the electrical component that is optimized for the drone. I am currently using DIATONE Taycan 3-inch Cinewook frame. In the video, there is also a buzzer attached. The function of buzzer is to signal pilot if there is something wrong with the setting before you fly the drone, or to locate your drone based on the sound signal if you crash your drone in the bushes. Frequently happen to me. The second component is a flight controller, or people call it FC. FC is basically the brain of the drone, which will read and calculate all the input data from your controller and gyro alignment of your drone before providing the output data. It plays the same role as your CPU or a GPU processor in a computer. This output data from FC then will be transmitted to the ESC. ESC, which stands for Electronic Speed Controller, will interpret the data and outputting it into how fast the motor will spin. Next will be the motor itself. As it is self-explanatory, without the motor, the drone will not be able to fly. The selection on the motor size is one of the important aspects while building your drone. If it is too small, the drone will be struggle to fly. On the other hand, if it is too big, it will add unnecessary weight to your drone and drain your battery. I'm currently using 1/4 size, which is recommended in building 3-inch Cinewook. Then the propeller. The size of propeller will depend on the size of the frame that you have been initially choose. For the frame that I use, it should be 3-inch propeller. In order to control and live view your drone via radio controller and FPV Google, you will need video transmitter and radio transmitter. I'm currently using DJI Air Unit digital system. The reason why I'm using this digital system over analog is because first, it will fit a HD video, and second, it is easy to build into the drone. To transmit the video and the radio signal from your drone to your FPV Google and radio controller, you will need antenna. I don't think there is no further explanation here. Macam nangga TV pakai Astro, mestilah kena ada antenna, sama juga dengan drone. Next, other miscellaneous parts that you might need is 3D printed TPU mount. This is not something that is important, but to make sure your drone look fancier. Plus, it is recommended as you don't want your component to drop out of the sky while flying your drone, don't you? Finally, the building tools, which consist of respective screwdrivers, tweezers, solder iron, and solder tools. Okay, now let's start building the drone. But before that, I think we need more euphoric beats. Okay, let's go. First, mount each of the motor into its respective frame placement. The reason why it is advisable to mount the motor in the first place is to ensure optimal wire length before soldering. Too long wire will cause a fuss in a later setup, but too short will not make it either. Just to let you know that all the screws will be provided along the motor purchase. In the video, you've seen me adding silicone pad beneath the motor before mounting it on the frame. The intention is to reduce motor vibration while flying the drone. Then, once all the motor mounted, cut the wire into suitable length based on the frame and solder it on the ESC pad. In the video, you might not watch me cutting the wire because the motor has been prepared before recording of the video. Another thing is, make sure you have the right skill to solder the wire. If you are not confident enough, ask for someone help to deliver the job, or practice on the soldering trend pad. Once every motor are soldered, mount the ESC on the main body of the frame. Make sure to mount the ESC at the center of the frame. Once the ESC has been mounted, connect it to the FC using the wire given in the purchase. Stack the FC on the top of the ESC mount. The reason why it is recommended to mount ESC and FC stacked at the center body of the frame is to ensure optimal flight characteristic of the drone. Then, assemble the motor frame on the main body frame using the screws and stand-off provided. Manage the wire of the motor to ensure proper entanglement. Then, connect the ESC with the DJI Air unit using the wire provided. In this build, I place the Air unit on the top of the ESC and ESC stack using the 3D printed TPU mount. Fix the camera on the given titanium cage of the frame before mounting it on the main body of the frame. Then, connect the ESC with the DJI Air unit using the wire provided. In this build, I place the Air unit on the top of the ESC and ESC stack using the 3D printed TPO mount. Fix the camera on the given titanium cage of the frame before mounting it on the main body of the frame. Join the bumper of the frame onto the main assemble. Connect the antenna extension cable to the air unit and mount it at the back of the frame. Screw the top plate of the frame. Join the GoPro TPU mount on the top of the frame. Screw on the antenna on the drone. Place GoPro camera onto its respective mount. Screw on the propeller. Make sure to place the propeller on the right place depending on your preferred prop configuration. Here I show you mine using prop in configuration where the propeller will spin toward the direction of inside the main frame from the front view. Attach the battery strap on the main body and hold the battery of the drone tightly using the strap. In this drone, I am using 1550 mAh 4S LiPo battery, which will give me 6 to 7 minute flight time. Finally, we are done. This is the final form of the Cinewoop drone build. See you next video where I will build a racer drone. Bye!